Good day, everyone. I'm James John, leading the CTR Product Engineer team. Today, I'm excited to take you through the CTR R&D Center design and development capabilities. Before we dive in, let me share a bit of my career. My name is James John. I'm leading the product engineer team in the CTR AM business department. Today's webinar has four topics prepared. The first is CTR R&D development capability. The second is the CTR product pictures and know-how. The third is production of CTR core products. And last is how to use the CTR web catalog. Okay, now let's begin officially CTR Technical Web Seminar. CTR Group R&D Center was established in 1990. Later in 2050, the R&D Center for the AM division was separately established. However, the AM division's R&D Center continues to maintain its 5 key competencies. 5 key competencies are research expertise and probe technology, advanced research tools, testing lab, material development. We have a diverse and specialized team of researchers. Our greatest advantage is that half of our research staff have design and development experience in the OE sector. CTR core technologies have already been patented worldwide. We use the latest design and analysis tools to achieve the optimal design that ensures customer satisfaction. Unlike our competitors, CTR conducts in-house and simulation. All our CTR development products are verified through the testing equipment. We are equipped with expert engineer and machinery to create products that meet OE level performance and quality standards. CTR as a specialized manufacturer of steering and suspension parts has a material development capabilities. A prime example is the special grease. We developed a ball joint which is applied to both OE and AM products. We have a specialized 5-step development process. It includes the project kill-off, design, analysis, fabrication, and finally uploading information to the catalog. The R&D Center of the AM division follows the same procedure as the OE R&D Center. The first step is identifying the product requirement, such as durability and fatigue life. In the second step, we design the prostate and select the material. In the third step, we confirm the final design through detailed design and analysis. In the fourth step, we verify the manufacturability through the testing. In the last, if our process passes, the design specifications are finalized for production. CTR ball joint and auto tie rod use the same material and production process as the OE parts. The R&D Center of the AM division follows the same procedure as the OE R&D Center. CTR philosophy is zero defect. CTR shares experience and know-how between its OE and AM manufacturing system. This video is about the CTR manufacturing system. Next, we'll explain how the suspension is constructed and where it is mounted. CTR core products including the ball joint, control arm, stabilizer ring, rubber bushing, and cross-axis ball joint. The main function of the ball joint is to connect the knuckle to the control arm, allowing vertical movement of the tire and steering movement. During the vertical movement of the beaker, the ball stud articulates around point A. During the steering, the ball stud rotates around the axis point AB. There are 5 important required qualities for ball joint. The first, ensure the articulation angle that follow the vertical movement of the tire. The second, maintain torque that does not negatively impact the movement or peeling of the steering system. The third, no pre-gap that could cause steaming or abnormal noise. The fourth, withstand operation environment such as mud, water, low temperature, and high temperature. Last, have sufficient strength and durability against the load input from the tire. The main function of the control arm is to maintain the correct vertical alignment of the heel. Basically, ensure that the camber axis does not become misaligned even during the beaker, vertical movement, or while steering the tire left or right. The main function of the stabilizer ring is to connect the stabilizer bar with the strut, knuckle and control arm. It provides the support when twisting motion occurs in the stabilizer bar and ensure proper rotation and articulation for beaker stabilizer during movement. The stabilizer ring of the CTR has a wide range of the application, depends on the size of the beaker and the quality required. The main function of the rubber bush and CABJ are absorption of vibration and shock, and providing flexibility to the steering and suspension systems. Last, maintain the suspension alignment. It provides support when a twisting motion occurs in the stabilizer bar and ensure proper rotation and articulation for beaker stabilizer during the movement. The geometry of rubber bush and CBJ is shown in the image. Next, we'll explain the steering parts are constructed and where it's mounted. CTR core steering products including the outer tie rod and inner tie rod. The main function of the outer tie rod and inner tie rod responsible for transmitting the force from the steering leg to the steering knuckle, the wheel. The outer tie rod, the CTR has a wide range of application depending on the installation method and quality required. And finally, how to use the CTR web catalog. Let's watch the video to learn more.
Check out the CTR Aftermarket for your auto parts needs. You can browse our whole catalog by visiting our Aftermarket page. Click the Catalog tab on the top of the website. Search for parts you need, sorted by location, brand, model, production year, and the type of the vehicle. You can also browse the new items list, which includes our latest releases and discontinued parts. CTR gives a frequent update on releases, so make sure to keep an eye out for the products you need.
This page is an explanation of how to use the web catalog. It should be easy for everyone to follow.
Right. Welcome to CTR webinar. CTR has been conducting offline technical seminars with comprehensive content so far. Now we have decided to tweak our strategy by additionally conducting webinars focused on the specific topics. So we are going to go into more detail than we did before with the technical content that you might be interested in. Before we go any further, please allow me to introduce myself. This is AJ speaking. I'm in charge of a CTR test lab. As you know, CTR has been supplying ball joints to almost all global oil automakers for a long time. That means CTR ball joints are installed in the vehicles almost everywhere in the world. In other words, we are very familiar with what the extreme environmental conditions are around the world. Based on that, I'd like to share our engineering information and knowledge with you here. This is what I'm going to talk about today. First, let's take a quick look at what the ball joint is. And the next is what happens if the joint is separated, and what types of joint separation are there, and what are the root causes of them. And the last I'd like to say is what are the preliminary signs before joint separation. This picture is showing that the steering and suspension system of a vehicle. The red highlighted part on the picture are 5 kinds of joints that CTR is supplying for the steering and suspension of cars. There are control arm ball joints, inner tie rod, outer tie rod, stabilizer link, and the cross-axis ball joint. The products listed here all have the different shapes and different names though. All of them have a ball and bearing in common. Today's topic is joint separation from a car. At this point, we need to be familiar with the name of each joint component. Those are cap, bearing, ball and stud, housing, ceiling boot, and clamp ring. Before we jump into the next slide, please remember the name of these components. If a ball joint becomes separated from a car while it's in motion, it can have serious consequences for the driver and anyone else on the road, because this can lead to steering difficulties or loss of vehicle control, making it difficult to drive and potentially causing accidents. That's why ball joints are designated as safety parts in the automotive industry. Let's see what types of joint separation there are. In the automotive industry, there is generally assumed that there are 3 types of joint separation in the car. The video on the left is showing that a ball stud is over traveled in the operating tilting angle and is separated from housing. The middle one is a ball stud just straight pulled off from the housing. And the right one is a ball stud broken by a dynamic cyclic stress. In the next slide, I will have the opportunity to look at what evidence remains for the 3 failure modes respectively. This is showing the concept of how ball and stud is separated from housing by over travel failure. When the ball and stud is tilted and it begins to touch the housing, the leverage effect is working. When you look at the parts where ball and stud is over traveled and separated from housing, we can see a permanent dent on the upper part of the housing, and the stud is bent, but not always. This is because ball and stud generally has the strongest hardness among joint components. This is the concept of how ball and stud is straight pulled off and separated from housing. When you look at the parts where ball and stud is just straight pulled off, there is generally no dent on the upper part of the housing and no bending deformation of a ball and stud. This is about how ball and stud is broken by dynamic cyclic stress. When you take a look at the general failure mode of it, there is no dent on the upper part of the housing and no bending deformation of the ball and stud, but it is just broken. This is a typical failure mode for dynamic cyclic stress fatigue. Now let's recap the previous failure modes. If you remember the differences among these failure modes, we may be able to tell at a glance what happened on them. The appearance sometimes gives us some idea of what type of separation has occurred on them. Now let's learn about the root causes of these separations. There are two main root causes in regard to balls that over-traveled. Regarding balls that pulled off, there are two main root causes. When it comes to balls that broken by dynamic cyclic stress, there are three main root causes of it. Now let me talk about them in detail one by one in the next slide. This is about one of the root causes of a balls that over-traveled. That is installing with the wrong part number. For example, a part number on the right side of a vehicle is mounted on the left side of it, or vice versa. Installing different part numbers could cause problems in the maximum operating conditions of the suspension or steering system. That's because permanent deformation of a stud begins to occur if it goes any further than a blue zone in the middle picture. Ball joint, outer tie rod, and stabilizer link may all have their different part numbers on the left and right side of the vehicle. This problem mainly occurs in the stabilizer links. Therefore, please make sure if your vehicle's left and right part numbers are different or the same before installing these parts. Here I want to talk about another root cause of a ball stud over-traveled. That is over-jounce, over-rebound, over-steering. The table on the left shows a designed over-traveled torque values and the actual test result for each joint type. Stabilizer links typically have lower torque values than the ball joints and outer tie rod due to the smaller ball size. Therefore, stabilizer links tended to have more problems with balls that over-travel than other joint. This is about one of the root causes of a ball stud straight pulled off. That is the static overload. The graphs here show ball and stud pull-off requirements and the actual test results for each joint type in the global oil automaker database. For example, the graph in the top left is about upper ball joint. X-axis on the graph means the ball sizes. Y-axis is pull-off force values. What's interesting here is that as ball size increases, the pull-off requirement do not increase proportionally. In other words, there's no pull-off force increase in the actual car, regardless of vehicle type or weight. The same goes for stabilizer link, cross-axis ball joint, and outer tie rod. However, for inner tie rod and the lower ball joint, as the vehicle becomes heavier, the stud pull-off load tends to increase proportionally. As a result, it can be predicted that the stud pull-off separation due to overload is very unlikely to happen in a real vehicle. Here I want to talk about another root cause of a ball stud pulled off, that is excessive wear of bearing inside the joint. This video shows the start of the wear durability test of the joint. The end travel curve before the wear durability test looks linear, as you can see, and it's considered as a good part. After the wear durability test is done with the good part, the graph could be slightly curved like this. It's still good. However, if foreign matters or water enter the inside the joint, or vehicle is driven beyond the designed mileage, the actual end travel curve lies horizontally in the middle part of the graph, as shown in the picture. We technically call this free play that may produce noise or vibration in the car. If this condition is left unattended for a long time, the stud eventually will be pulled off or broken. In other words, this can happen if the driver has not had a chance to notice the various symptoms of the problems. This is about one of the root causes of a ball stud broken, that is the dynamic overload. In the automotive industry, joint suppliers conduct a kind of a test based on the assumption that a vehicle would be subject to a high loads close to its yield point 1 time to 100 times over its lifetime. When heavy load is applied, as shown in the video on the left, the part experiences elastic deformation repeatedly. After the test is successfully completed, the actual end travel curve on the joint could be slightly bent. In the middle part of the graph, though, there should be no screw loosened nor broken parts. If the test fails, there could be a free play, screw loosened, or a component broken. There's another root cause of a ball stud broken, loosening of screws. If your vehicle's screws become loose, they will initially make noise or lose functionality of the part, eventually causing parts broken. If we tighten a screw to lower than the specified values, the screw may loosen while the vehicle is in motion. On the other way, if we tighten a screw too strongly beyond the yield stress, the screw may also be broken. I'd like to give you a little bit of a principled explanation as to what's going on. In general, eye-tightening torque conditions are determined in the elastic region. However, it tightened at the outside of the elastic range, the screw may be permanently deformed or broken if the extra load is applied on the car in motion. That's why screws must be properly tightened according to the instruction provided by automakers. This is last root cause of a ball stud broken, corrosion inside the joint. As I previously explained, the excessive wear of bearing, the end travel curve should be linear at the beginning. But if there's water intrusion inside the joint before or during the testing, steel component inside the joint get corroded and may produce noise or vibration in the car, like this. If this condition is left unattended for a long time, the stud eventually will be pulled off or broken. Now let's find out what preliminary signs appear before the joint is separated. These are preliminary signals before separation of joint: noise, cylinder status, and free play. The preliminary signs listed here are ones that drivers may recognize and notice on a regular basis. If a driver begins to hear noise from a vehicle's steering or suspension system, it must be a preliminary sign that there is a problem with the components. Here are some examples of a noise generated by joints, a squeaking noise here. And in reality, this squeaking noise does not occur directly inside the joint. A slight vibration occurs at the joint first, and the vibration is amplified in the connected part, resulting in noise. We measure the friction torque of a good joint. It'll look like this, but noise part will be like this. Yeah, this is spike shape in the friction torque causes vibration inside the joint, eventually resulting in noise in a connected part. Now let's listen to another type of noise, clunk noise from stabilizer link. This noise comes directly from the inside the joint of a stabilizer link. When you separate the part from the vehicle and measure the actual end travel of it, the good part will look like this. It's linear. However, the noise part will be like this, typical free play inside the joint. Let's listen to another noise that can be heard from the inside the car when operating the squeaking wheel. Yeah, this is also caused by a vibration inside the joint, and the vibration amplified in the connected parts, resulting in noise. In any case, if you hear noise, this is a preliminary signal that you need to take some actions. If you have a chance to take a look under the car, we might be able to get more information. If the ceiling boot fails to prevent the foreign matters from intruding inside the joint, the lifespan of the joint will be drastically shortened. Here I will show you the typical failure modes of a ceiling boot classified in the automotive industry. Punctures are caused by an impact from a hard object or tool, often caused by objects bouncing off the road, sometimes created while people install the joint on the car. If a slit or a crack on the ceiling boot occurs in the horizontal direction, it is most likely due to wear. As the ball and stud in the joint move repeatedly in the tilting angle, the ceiling boot wears out due to contact with the rubber itself or contact between the rubber and the housing. If the ceiling boot is torn in a complex shape like this, there is a possibility that the ceiling boot design is bad. I will show you why it is a bad design of part in the next slide. This video at the top show what good ceiling boot look like when installed in the mating part. The shape of the good ceiling boots looks smooth after assembling to the mating part and appear to have the right amount of air inside. And the videos at the bottom show what bad ceiling boot look like when installed in the mating part. Do you see the difference between good parts and bad parts? The bad ceiling boot become wrinkled and distorted after assembled with the mating part. What would happen if I drop the car with these bad parts installed? Now let me show you what happens. Car makers in the automotive industry have its own environmental simulation test requirements. As the joint moves, the atmospheric temperatures goes back and forth between extremely low and high temperatures, and water mixed with mud and salt is periodically sprayed onto the joint. Here's an example of an environmental simulation test results conducted by an automaker in North America. Good-shaped ceiling boot appeared to have no visible abnormalities until the 17-day testing is completed. But better-shaped ceiling boots were found torn just on the second day. In other words, if the ceiling boot is assembled in better shapes, the service life decreases to less than 1 out of 10 of a normal boot. Last but not least, this is about free play as a preliminary sign of a joint separation. If you can lift the vehicle using some kind of equipment, you can try shaking the wheels. If you feel a gap while you are shaking the wheel from side to side or up and down, it must be one of two things: free play inside the joint or screws loosened. If the free play is not due to fasteners loosening, a gap must be created between the ball and bearing inside the joint. There will be almost no friction torque like this graph and typical free end play. This free play is likely to eventually develop into noise. On the other hand, good parts still have some friction torque values, and the end trouble is linear or close to linear. Now let's recap what I talked about today. There are three kinds of a joint separation: over traveled, straight pulled off, broken by a dynamic cyclic stress. You could estimate the root cause from the type of a joint separation. I talked about the existence of a dent mark on the upper part of a housing and bending of a stud. You should install the joint with the correct part number. You must check whether or not the left and the right part numbers of the vehicle are different before installation. Screws must be tightened to the correct values according to the instructions. They should not be over-tightened nor under-tightened. Abnormal shape of ceiling bush should be corrected. Please take immediate action if the bush shape is found to be wrinkled or distorted under the car. Joint separation could be prevented through a periodic observation by monitoring noise, the ceiling bush status, free play, and so on. You can avoid the worst case scenario. This is all I have today. Enjoy the rest of your day.